So I'd love to welcome Jared. He's the VP of AI at Vercel, which hopefully a lot of you use to power your front ends. He made it to the company through the acquisition of his prior business. Vercel, as many of you know, are the creators of Next.js. And they, led by Jared, have been working on this new product called V0, which I think he'll show you how it works and give you the pitch. But I think it's a pretty magical experience to start building front ends. And so with that, Jared, thank you for being here. And over to you.
Sure. Thanks. Yes, I got this right here. Hi, everybody. I'm Jared. Today, we're going to talk about building generative interfaces. But first, a little bit about me and Vercel. So Vercel is what we call a front-end cloud. And we are a very, very high-performance web hosting company. We host the front ends for companies like OpenAI, Under Armour, Johnson & Johnson, Chico's, Zapier. And we also maintain one of the world's most popular web frameworks called Next.js, among other projects. And what's interesting about Next.js is if you, I think it was like Andreessen Horowitz published the top 100 consumer AI applications, and 50% of them are built with Next.js, and I think, or hosted on Vercel. So we sort of rode this wave of generative AI, and our web framework happens to be the same web framework that ChatGPT uses, and Perplexity uses, and Anthropic uses to build Claude, and Mistral uses to build LeChat. And as the head of the AI group at Vercel, my job is twofold. First, is just to make sure that Vercel is continually to ride this AI wave and make sure that our product services and developer tools are adequate and maintain their position in the stack as the de facto framework for building this next wave of application and to deliver on the next generation of user experiences. In addition, my job is to create tools and services that augment the developer experience. So sort of two pillars there. So as we discussed, AI is going to change how software is built and how we experience it. And so as you can imagine, being the champions of the web, AI is super important to us. So, and what I mean by, I also would like to just level set that the way we think about developers is a little bit different than I think the way we thought of them a couple of years ago. We really mean like everyone now. Thanks to generative AI, truly those of you who used to copy and paste from Stack Overflow, I myself included, the barrier to entry to software development is getting lower and lower. So we really mean everyone. But today we're going to talk about what the future of software looks like in human-computer interaction and how we're going to get there, and the programming framework that you're going to probably use to build these types of experiences. And then we're going to culminate with an actual demonstration of the furthest generation future that we were able to come up with at the time. And what's interesting about this talk is that, you know how there are quantum computers and they can kind of prototype the quantum computing logic already, even though there really aren't quantum computers yet? They can just theorize about it. There are theoretical programming frameworks. Well, what's interesting about this talk is we have a similar situation with theoretical generative interfaces. We actually have, which I'm about to show you, developed what we think is the correct technology for building generative interfaces. The only thing now that's lacking is the speed of the models. So along this transition, as my job is to, at Vercel, is to build programming frameworks. And Next.js was designed as a sort of software 1.0 framework, Alan Turing style, just focus on determinism, if you will, right? So transitioning our web framework Next.js into this software 2.0, Andre Karpathy style, why we're all in this room, is new for me and new for us in the web community. I'm sure all of you here, if you're here, you're sort of self-selected, this is not new. But for us, this is new, or new-ish, I'd say. So in thinking about how we can support these new and generative workloads, we've had to change our frameworks. And while we also need to set up our framework so that we can build ahead of what's coming, But it's helpful to look at like the differences between who we're building for and the difference between like where we were probably, I don't know, a couple of years back, sort of in the ML wave, and where we are today, like just in this new AI wave. And I'll just differentiate between these two, even though probably gonna piss people off in this room, but like whatever, okay. Yeah, this is the reality, right? So this ML wave, when you probably started this conference, it was mostly Python, right? And it still is very, very much a Python thing. But the AI wave of the last couple of years or so has really been powered by TypeScript, and that's the argument I'm gonna make. And my argument also is that in order for Jensen Huang to make a return on all those chips, I mean, trillions of dollars of product value needs to be built. And the language that that's gonna be built in is TypeScript at the end of the day. It's gonna be likely on the web. So there are just like fundamental differences between these two different sort of waves. And we have, the ML wave in the past is really for probably the people in this room, not to generalize, but like a very small subset of the universe was able to have access to the ML models of the past. But now, thanks to these new types of services, using AI in your application is just as simple as making an HTTP request, right? It should be so simple, but it's not, because these HTTP requests are actually kind of weird, right? ChatGPT, if you're not familiar, has a very long request time. It streams incrementally. And the requests can actually take upwards of like 30, 40 seconds, at least they used to. And so that programming model is a little weird for most TypeScript engineers, and so they need a little help. And so my goal at the AI team at Vercel was to give them that help and the abstractions that they need to build this next wave of generative interfaces. And at the same time, build such that we can extend our programming framework so that we can build ahead of what's coming, right? So we have this expectation that we just assume that reasoning is gonna get better, the models are gonna get better. And whether you believe that like we're actually in this exponential curve or if we're in like sort of a sigmoid sort of thing, right? Like we're just in the inflection point, it feels like there's like another round of this. That's my hot take. But whether it is this transactional interfaces that we're familiar with like chat or asynchronous interfaces and experiences like agents might be, we need programming tools, right? You need to make products out of this. You cannot ship a Python notebook to users. It's really tough. But you can ship an app. And so what does that look like and what's that programming model? And so to sort of set the ground here, the way I think about this is in sort of 3 generations of chat, which is the primary use case, although I loved the last talk because it's a non-chat interface, and that was awesome. But chat is, I would say, the large majority of what people focus on right now. And so we're already sort of into this like, I think there's like 3 generations of chat interactions. So we had the classic like text-based stuff, like it's 1981. And it's this, right? So it works really well, right, until you need some information about the outside world. And then you're kind of screwed, and it's laughable, right? Like we all remember that. But it's awesome because you can create poems, you can create rap songs, you can do your homework, you can do math, but you just have no grounding in reality. And so what did we do? These software 1.0 hackers got smart, and they're like, we could totally get around this. If we prompt engineer, we can do this thing with tool calling or function calling. We can get external information and do retrieval augmented generation. They even made up an acronym for it. And then you get this information about the weather outside, right? You can access external oracles to give you more context. But like I'm a product engineer, and this is a horrendous experience, right? That like it's not 1981, it's not MS-DOS, right? This is terrible. This cannot be the future. This is like the way we're going to interact with computers is kind of laughable. So where we're going is where we're basically getting to is this sort of generation 3, I'll call it, chat interface, which includes components like UIs. Steve Jobs would be happy. They have rounded corners, and fonts, and colors. Amazing. But how do you build that? How would you build that? So that got us on a journey. So it turns out that React, if you're familiar with it, is actually all you need. So how many people here in the audience know about React? Okay, cool. That's a lot more than I thought. Great. So for those who don't know, React is the UI library created by Facebook around 2013, 14. The core contributors now work at Vercel, but React was incredible because it was this idea that you could componentize an interface into its like atomic parts and co-locate and mix a lot of concerns. But if you did that, well, then you could scale not only an interface, but also an engineering organization quite well. But it actually started, so it already sort of has this componentized model, which if you remember, like what I just showed you in the last slide, is kind of reminiscent of what we had, right? It's a sort of componentized mini UI. It's not a full app, it's just like a little card here, right? So there's already kind of this hints of like this being the right programming model. But the way that React was built initially, if you recall, this is gonna be a throwback, I'm gonna date myself, but do you remember Facebook? Right? Facebook had a little chat window and it had a notification, like you had your notification list. That's really where React started. It was on the client side of the browser it meant for those two little UIs. So Facebook.com is written in XHP, PHP, an advanced version of PHP, and it would bootload, but then they load React on the client. And it turns out though that like that didn't scale either. So the open source community embraced React, and Facebook had this sort of interesting relationship with it where it was going to invest in it as an open source project, but not give everything you needed to build full applications with it. So the community invented what it had to, and there was this whole craze around client-side rendering, and that kind of worked, but ultimately is not what is the correct architecture for what we're going to need, which is that you need enormous amounts of dynamism for generative interfaces. And the reason for that is if you think about what would make a highly, highly efficient and peak performance dynamic interface, you actually want to lift as much work as you can to the server. And there's good evidence for this. So Facebook itself, all of its newsfeed variations are all server rendered. Google, when you go to type in like, what's 2 + 2? And you get the calculator. Or you type in, when's the next F1 race? And you get the F1 calendar. Or you ask like, who is Chuck Norris? And you get the IMDb thing, right? You don't download the calculator when you're searching the F1 schedule, right? That's all server side. No way Google would like sacrifice performance for irrelevant code for a given query. And the same thing is true. And so React's actually been moving to the server this whole time, and it turns out that the React team has actually been researching this for quite some time, and they already have a component model and a server-driven model that is exactly what you need, not just for like high-performance e-commerce or media or web applications, but also for the most dynamic interfaces of them all, generative ones. So to make this all easier to use, we actually built a bunch of stuff. And we then did something rather crazy, which is that we open sourced most of it. And we actually got hold of the NPM package AI, which is my favorite, which was pretty cool. We have billboards in SF that have made the news. It just says NPM install AI. That's the whole billboard. It's a little wild. But what we did was we basically built this abstraction layer to help developers start building this stuff. And the AI SDK, as it's called, helps developers integrate language models into their front-end applications. And you can think of it, it's not just for React anymore. It's for Vue and Solid and Svelte. But you can kind of think of it like an ORM. But what an ORM does for databases, this does for language models. Because what we found was that when you were to go integrate language models across providers, it would be really, really leaky because they all have unique SDKs, they have different streaming formats, and every time you wanted to test something out, you need to like, rewrite large swaths of your application just because to deal with the nuances between providers. So like any good software 1.0 developer, we built an abstraction. And so this is what it looks like. So there's actually a bunch of different methods. This is for OpenAI, and this is the simplest one, like generate text. And there are a bunch of other methods too. They're decoupled the model itself from the modality of usage. So we've got generate text, we have stream text, we've got stream object and generate object, which would have really, really helped out with the last interface, generate object and stream object. Because this allows you to pass, those two methods allow you to pass a schema, like a structure, to the model, and it coerces the shape So if you're doing the thing in the last talk where you're trying to coerce a specific output shape, you could use this very easily to force the model into doing that. And if it fails, it automatically retries until it forces that shape. But what's also really powerful about this abstraction is that you're not just like, the rest of your application can frolic and expand in complexity. And if you change providers, to Anthropic or to between OpenAI and Anthropic, just a couple lines of code, but it's encapsulated. And so that's very powerful. And what we do at Vercel is we actually lift a lot of this configuration up into feature flags so that they can be controlled from a separated control plane, so that this can be more responsive, and we can do more and more tests. But in general, this has helped a lot of developers now build with generative AI, but we weren't done. We wanted to build abstractions for developers to do stuff like tool calls and get to like Gen 2 chatbots. So this is an example of a tool call with the AI SDK. You get sort of same thing. You can pass in messages and you can pass in tools. And what's fun is you get the schema, which is uses a thing called Zod it's like a pedantic, but in TypeScript, where you can pass a schema. And then if that particular tool is called, you can retrieve external information, in this case, get flight info. And so we'll just do a little demo here, like what's the status of my flight? And presumably you get that information and it would show it in text. But as we mentioned, like this is still like not where we want to go. This is the basics. Where we want to go is like beyond plain text. So what does that programming model look like? So that programming model, in our mind, allows you to bind React components to tool calls and lets you use all on the server. It almost lets you take tools and almost lets you think of them as like URLs or routes. And the way that works is you basically you can use your existing React components or new ones that you build. You define a schema and a prompt. And through the AI SDK, you're going to bind those to specific tool calls. And those tool calls are going to give you data back and then bind to a specific React component for a specific task. So instead of focusing only on the data, you can do the data part and you can return that component. And that component is just React, which is really powerful. So what this looks like in practice is very similar to the last slide, but in this execute function at the bottom, we go beyond the get flight info part. We actually can use React suspense and React server components and just return the UI itself. And so like walking through this, like again, what's the status of this flight? We'd have these prompt and tools, and breaking it down, it'll call get flight info, and then presumably our service says the flight's going, it's on time. And then we can actually render the UI component, flight info. There's no intermediate step there. And there's no extra round trip. Thanks to server components, just like Google search, the component is streamed on demand with no extra round trip. So you may have tried this in the past using a client-side approach, but the problem with that approach is that as you add more and more components, your manifest gets larger and larger and larger, and on top of that, if you lazy load those components, you're going to do an extra round trip. And so that's not sufficient for an app like Perplexity, for example, which is highly sensitive to latency. And it's just not as performant either. You're just bloating the bundle and delivering a worse user experience. So that's why ChatGPT and Perplexity are adopting this model, because it's peak performance and they can scale across multiple like modalities or tasks, right? So whether you're writing or working on the chart or in the DALL-E thing, or this thing can scale no matter how much code you throw at it, because you're only incrementally hydrating and streaming the code that's actually being used. So the other thing that our AI SDK allows you to do is allows these components to be stateful. And on top of that, it gives you a programming framework to expose that state to the language model itself. And so let's look at what that looks like. So imagine you wanted to change your seat. So you'd set this up and you got the get in seat info, show the seat picker, change the seat. And you'd show a component looks like this. But how would you represent like the actual seat change? Well, you could just use React to do that. And then we give you a little bit of a tool to help you write to the chat history so that the next time the model or even if the person interrupts the chat, and I'll show an example of this in a second, they're aware of the context of what's gone on in the component. And so at all times, the model can be aware of the interactions, which is a really important thing that we found when we started to build some of these applications. So let me show you what we actually built what I just showed you. We demoed this at Google Cloud Next, and this is using Gemini, and it's using Gemini tool calls, and it's using the Vercel AI SDK and Next.js to show what a sort of generation 3 flight checkout would look like. So let's watch. So could have typed it out, but whatever. So let's list some flights. I'm gonna click on a flight, start the seat picker. It's stateful. Either way, we can proceed to checkout. This is an agentic behavior, so it'll be multiple steps here. And as these updates are coming, we can stream different UI. And finally, we can see the checkout and get our boarding pass. Pretty neat. Cool. So another demo of this sort of stateful interaction is a calendar. So this is a chatbot that we built for our own conference. And it can do regular text-based chat. So this is just regular streaming text. But then this now query is scheduling a meeting with Lee, my friend, today at 2 p.m. And this is going to render a calendar. And I can modify that. It's fully interactive. Whatever I want there. That's cool. And I can then presumably zoom out. I might move this around. And as I move it around, it's appending messages to the chat. And that was just something we built for this demo, but not necessary. Cool. So another really stateful demo, and this is going to drive the stateful part home. You'll see what I mean here. So when you watch this, this is a financial advisor. And this is a chart. It's supposed to a stock price, right? And now we're going to purchase stock. But here, let's just say I only have $5,000 instead of this $8,000. And I adjusted the widget. And now look at this query. Can I afford it now? And the model was aware of the stateful change. Did you catch that? Pretty awesome. So the way that works is in the AI SDK, we have these two concepts, AI state and UI state. And we give you the ability to sync them together and write to a singular chat history. So no matter what happens in the browser, the model is fully aware to whatever you want. Whatever you want to describe the interface, you're fully able to. We can go back and look at that one again. Yeah. So basically, you can just write it in plain text, almost like just an extra entry in the history. In this case, it was the slider's value is blank. And that's actually all the model really needs to know about the state of the interface for you to query against it. And since this is synced in almost real time, you can ask it about intermediate states. So this breaks the mold of this transactional model that we've been working with ChatGPT for the past year and a half or so. So I'm excited about the future here. And as we work towards this generation 3 UIs, there's actually another layer to this. This is all using pre-built React components. And whether the props themselves and the properties past these specific components is generative potentially, or I don't know if you want to call it that, but it's extracted from the message or inferred or imagined. There's still another level to this, and that's where we're going, which is really fully generative interfaces, ones that are built on the fly. And I want to talk about those for the rest of this talk. And what's interesting about these interfaces is that I don't know if you would call it a spectrum or a gradient of generativity. I don't know if that's really the word, but how generative are we talking? Well, in practice, we've prototyped, not just prototyped, we've shipped a system that actually emits an AST straight from a model and generates code directly without any intermediary step. And we actually built a product around this. It's called V0. And it is at first used for design, because that's actually a really great use case for this type of technology, is to actually use the generative interface behavior, not for fully interactive widgets, but for just layout. And so we built this, and what this tool does, V0, is it helps developers kind of get started with different designs. and they can go from text or screenshots to valid UI code built with React in a matter of minutes. And so, but what's interesting about the technology behind V0 is that it actually is a fully generative interface. And I'll show you what I mean by that. So I recorded this video earlier. So I do an AI conference talk submission form for RAAIS conference 2024 in London. And this is now going to generate a full UI. It's going to generate a form on the fly using React. And it gives me 3 options. I think this one was the best. We'll zoom in here. Sorry, I sped this up. And you can see the code on the right. You can edit the code, which is fun. I can also like keep making prompts. So I'll make the whole thing 2 columns. On the left should be a form, and on the right column should be information about the event itself, along with testimonials. So we chose one of those options, and now it's gonna, we call this reprompting. And so now it's going to take what was, and it's trying to fix it up to the prompt there. And that testimonial thing is cool. It did what we wanted, but it's kind of ugly, right? Like the test is aggressive. So let's tone down the testimonials and make them more subtle, is what the prompt was. It thinks it's a robotics talk, which I found interesting. What's weird is it's actually very good at copy. I have theories why it's good at copy, but it's quite good at copy. So check out the text there. You can edit the text if you want to directly, edit the code directly if you want to. So let's delete a bunch of the stuff because that's wrong. Press save. We can also pick and edit a section and say, let's add logistics about the event too with icons. And then it's going to add the extra logistics down there. So we made some progress here. And so I don't know how long this would take you, depends on your design skills. You may have not needed a designer to begin with, but the point of this part of the demo is that this is just the beginning. And we expect as these models get better and better and better, that this will become more and more compelling way to design. And the reason for that is if you think about a tool like Figma, or Photoshop, whatever you want, or Sketch, these are intermediate representations of the thing you want. You want the UI. So with V0, our idea is that like, well, what if you could just design with your own code? And along the way, we built all of this generative technology so that you could see the code as it was being rendered. But there's still some problems. Like the code here is static, as in like the individual components themselves can actually be interactive, but for the most part is completely static. And that was initially for security reasons, but also for performance reasons, right? You want to see this stuff as it comes down. And the other thing too is like, you have to be careful when you're evaluating like code written by an LLM. So to get to like fully generative, like Minority Report, I don't know, matrix UIs, just futuristic stuff, we have to solve some security issues. At the same time though, you can kind of see this coming. And this is what it's mostly going to look like. And what's interesting, as I mentioned this sort of the quantum computing parallel here, is that like we're very confident that React Server Components, which is what this is built on top of, is the right protocol for delivering these types of interactive and generative experiences. And so we've actually started to leak these out into the service. V0 is already public. We've had about 3 or 4 million generations, so you can try it yourself. But I wanted to show a little glimpse of what's next, and that's will be sort of the conclusion of our talk here. So what's next is these fully interactive applications that can really do stuff, right? They're not just read-only. It's not just for design. They might actually do things. So I built one, or I prompted one before. So let's play this. This is a Canvas app. So a Canvas drawing app that works and use React hooks. That's all you need. It's pretty funny. You just need that. So this one's fun. So if you're familiar with like TL Draw or Scala Draw, that's what this is going to cook. And it's going to work. And there's all the code for it, which it generated. And it totally works, which is fun, even the brushstroke. That was done on demand in a relatively short period of time. And then I drew, yeah, that was the whole board. There you go. smiley face. There you go. Cool. Copy the code. So the idea is you copy the code still and put it into your application, but you can imagine a future where this is very much wired into the operating system or the web site that you're on. And this is where we think the world is going to end up within the next 18 to 24 months, is with these generative user interfaces. But in the meantime, I think you're going to see a slow pace of adoption here, where probably a better term is adaptive. They're going to be hyper-personalized. They're going to start super small and sort of grow out from there. And my hunch is that in the future, certain apps on your phone and websites will have the right to stay, if you will. Like the Facebooks and the TikToks and the Instagrams, they've sort of earned their right to an interface in your life. They have, sorry. But there are certain apps and services. I'll pick on Delta for a second. I'm flying home after this. Do I need a Delta app on my phone? I don't know. Do I need to go to the Delta website? I'm not sure. What I'd love to be able to do is kind of have that experience that I had before, if I need to change my flight, and have that be like a fully dynamic, potentially slightly generative interface. And what's interesting is that that interface doesn't need to be generated very often. It might be generated for a handful of people. It might be pre-made. It might be some gradient between the two. But that's where I think this ends up, which is like maybe there is a Delta app, but for a vast majority of users, whether that be on an iPhone or whether that be in a web browser, some of this stuff ends up being highly generative. And to get there, we need one more model upgrade, I'd say, maybe two, in the speed. So the biggest constraint to something like this being like really viable in a time frame that is acceptable to most users is speed. So I'd say the fastest models out there right now, like a Grok, Mistral model, is about 1,000 tokens per second they clocked, or a Llama. You really need like 10,000 tokens per second to make this feel almost instant. Obviously, so this was all sped up. But I think that's going to be the next key unlock. But what's fun is that we can already start building for that future today. And we can already start building the programming models for that future today. And we can release tools like this and others that kind of build ahead of where we are. And we can just let the models kind of catch up to us. And so by the time that we do get models that are fast enough and smart enough to build these fully generative interfaces and experiences, our plan is to have the programming framework ready, willing, and totally tested and battle tested so that these new types of experiences are easy to build and easy to make and safe to use. So with that, I want to say thank you, and thank you to Nathan for inviting me here, and thank you all.